Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. Welcome to another webinar by Data Platform Geeks. Today's session is on deep dives into storage and data pools in SQL Server 2019 Big Data Clusters. And our speaker for today's session is Niels Berglund, who's the Data Platform MVP from South Africa. My name is Arti Nambiar, and I'll be a host for the next few minutes. And Sonal Badkar is helping me with the moderation. Before moving on with the webinar, I have a couple of slides. We represent Data Platform Geeks and SQL Server Geeks communities, which are two separate communities. Dataplatformgeeks.com is, you can log into it and you can find out our upcoming events and webinars. You can also get access to all the webinar recordings, events, event resources, blogs, technical blogs, etc. And in SQL Server Geeks, you will find lots of technical videos and blogs as well. So once in a year, we do this learning event called as Data Platform Summit in Bangalore, India, which I'll talk about it later. You can even check out our social media channels if you wish to follow us in any of the social medias. You can just check it with bit.ly/DPG social. The links are available in the chat window. So as I was talking about a learning event called Data Platform Summit, this is the 6th year which will be conducting the summit this year. So you can see the themes for the past 5 years on the right side of the screen. And for this year's conference dates, we'll be announcing them shortly, maybe in a few weeks. So here's the group picture taken at DPS 2019, which we had organized in the month of August at Bangalore. So we had more than 1,000 attendees who had participated in this conference and who had traveled from 16 different countries. There were more than 100 sessions based on 7 technology tracks, and we had more than 60 speakers from 20 different countries. So if you're a person who works on data, AI, and analytics, this is a must attend summit for you all. This summit, you get to meet and network all the product makers, MVPs, Microsoft certified masters, industry veterans, and your peers from different industries all over the world. So we'll be announcing the dates for this year's conference in few weeks. A big thanks to our core team members who spend time from their schedules to contribute to the community. Amit Bansal, who's the founder and president of the community, and we have Manohar Putna, who's the vice president, and we have others who represent data platform community from different cities. Apart from the DPG core team, we have eDominer teams also help us with organizing and managing the events pan-India. And a special thanks to Microsoft for helping us with all our community efforts. Knowledge partner for today's webinar is SQL Maestros. You can visit on the website sqlmaestros.com to know more about their offerings like hands-on labs and video courses. Very shortly, we'll be launching video courses on SQL Server performance tuning and T-SQL querying and programming. So if you wish to learn more about the video courses and SQL Maestros offerings, you can visit sqlmaestros.com or drop an email to contact@sqlmaestros.com. You're all members of Data Platform Geeks. Remain as a member and you get notified to all our in-person events happening at different cities in India and also webinars. You will also get access to lots of free videos, labs, magazines, etc. Once in a while, we do even we put up free hands-on labs for the community. So kindly whitelist the Data Platform Geeks domain and add events at dataplatformgeeks.com to your address book so that you don't miss out any of our events. So beyond this webinar, if you have any questions, you can follow us or join us in any of the social channels. We will pass on to the questions to our speakers, and or else someone from the community will definitely answer them. So bit.ly/DPG social is the link where you can find links to all our social channels on Facebook, LinkedIn, Twitter, and Telegram channels. You can also give your suggestions as on what tracks or technologies you need sessions or in-person events or webinars. We'll definitely try to arrange sessions on it. So you can either follow us or join us as per your preferred social media, social channel, so that you remain connected and notified. So without much delay, let me hand it over to the speaker. Before that, I have a poll to launch. So I hope all of you can see the poll on your screen. So have you attended the webinar on big data cluster on Tuesday? So you can either type yes or no. I'll just wait for a couple of minutes. Okay. So we have 70% of the attendees who had attended the session earlier on Tuesday. So Niels, you can take over.
Thank you so much. While I'm sharing my screen here, I just want to thank to all of the attendees for taking time out in their busy schedule and coming to listen to little me here. That's awesome. And I also want to thank Data Platform Geeks for arranging all these community events. That is absolutely fantastic. So thank you guys. Thank you so very much. I have started sharing my screen. Can someone indicate if they can see or not? Cool, thank you so much. All right, so welcome. Storage and Data Pools Deep Dive 2019 Big Data Cluster. Let's go over here and continue. Right, so this is me, Niels. I'm a software architect at the Ribco, and I'm Microsoft, as was said in the beginning, Microsoft Data Platform MVP. I'm presenting at various events, and I certainly hope I'll be able to present at the summit later this year. And I work quite closely with Microsoft around various bits around SQL Server, and that can be language extensions, that can be big data cluster, etc., etc. Right, so today we'll start with talk a little bit about the architecture of a big data cluster, because that has an impact on this storage pool and data pools, right? We will talk about what are these things called pools in general, and then we will go on to the meaty part of this and have a look at the storage pool, followed by a look at the data pool. So that's what we'll do. So remember, for you who attended this Tuesday, you remember how I say that we are getting more and more and more and more data, and we need to handle that data. We need to analyze data. We need to manage the data. We need to do various stuff with the data, and the problem is that the data doesn't really sit in a nice SQL server. Right? They sit everywhere. It is SQL servers, there's Oracles, there is Hadoop, there are Excel spreadsheets, you name it. That's where the data is. And Microsoft now, I mean, Microsoft realizes this, and what they want to do through the evolution of SQL Server, they want to be able to make SQL the central data hub for all your data. So regardless if it is SQL data or Oracle data or whatever data it is, they want SQL Server to be central to all that. And that's why they introduced this SQL Server 2019 Big Data Cluster, which is essentially not only SQL Server, but Apache Spark, Hadoop file system is coming part of the installation. And why Microsoft is doing this is that they want now to be able to store data in the petabyte range. And that is also right now why Hadoop is in there. So we're not talking about relational data here. Well, We're talking about relational data, but we're also talking about other types of data, such as delimited text, such as Parquet files, etc., etc. And the whole SQL Server 2019 Big Data Cluster that runs in Linux containers on Kubernetes. So you may have attended a webinar in December last year, where I spoke a little bit about Azure Big Data Cluster and, about SQL Server Big Data Cluster, and how I said that this is no longer the SQL Server we know and love when we are talking about installation, for example. So instead of mounting a ISO file as we normally do here, we're now executing Python scripts which will grab Linux containers and deploy that into Kubernetes. So this is a completely different beast than your normal SQL Server. Right, and this kind of the scary image, as I call it, shows what a typical SQL Server big data cluster looks like when you're installing it. How we're having here the thing that we call the controller, and here, this part here, this is the SQL Server that we normally work with, right? That is now the server instance that we are working with in a normal SQL Server instance. But if you're looking at this picture, you're seeing how that has a very small part of the big pictures. And we also have SQL servers all over the place here, right? So we're having in the data pool, we're having in the storage node, sorry, I'll get rid of that. And Kubernetes nodes, and underlying this we have some persistent storage. And we'll come back to this picture a couple of times in this presentation, but I just want to do this so you're realizing that this is somewhat different than your normal SQL Server installation. However, one thing that is exactly the same is this, right? We are accessing all this now. We are accessing this data pool instances, this HDFS instances, whatever it is. We are accessing that through your normal T-SQL, the normal T-SQL that we know and love, right? So in that respect, nothing much has changed. Right, so Kubernetes, just a couple of words about Kubernetes. So we're having some components of Kubernetes. So we're talking about Kubernetes nodes, and those are essentially worker machines, and that can either be a virtual machine or physical bare metal. On the node, we then have what we call pods, and in a pod, we have containers. So, for example, we have a container for HDFS, we have a container for SQL, compute instance, etc., etc. So, pod sits in a node, and they are containing containers. A cluster is then basically a group of nodes, and in Kubernetes, you have the notion of cluster and you have the notion of namespace, where basically a namespace is a virtual cluster of nodes. So you can create a Kubernetes namespace, deploy stuff into there. You have one Kubernetes installation, but you can deploy multiple kind of application systems into that Kubernetes instance, into that Kubernetes installation, and they can be isolated through this namespace thing. Then Kubernetes is essentially kind of stateless, and that is obviously then a problem when we're having something like SQL Server or Kafka or something that requires persistent data, and that's where volumes comes in. So you can assign volumes to pods in order to then, so the volumes contain the storage, right? And you are assigning that to a pod. The pod can come down and up. A pod can go down, and a new pod is being spun up instead of that pod that just went down. But the whole notion of volumes here is then that the volume will now be associated with this. So we will not lose any data, hopefully, right? And then finally, we have something called stateful sets, and that is essentially something that handles deployments, scalability, etc. And you are deploying stateful sets when you want persistent data. You also have something called replica sets, where you are not guaranteed persistence. So that's Kubernetes. So if you notice here in what I have highlighted here in the big data cluster slide is this application pool, compute pool, storage pool, and data pools. So what Microsoft has done is they have kind of, so we said that a pod is a collection of containers, and a pod lives on a node. And then you can have multiple pods on a node, etc. But what Microsoft has further made this a little bit further granular by introducing the notion of pools, where a pool has a certain set of behavior. So we're having the compute pool, the storage pool, data pool, application pool. I will talk about that and that is a complete Microsoft thing. It's nothing really that in Kubernetes, you doesn't really talk about pools, but in a big data cluster, you talk about pools. So then a pool, it's where we are logically group services in a big data cluster. And as I said, the stateful set then make sure that this grouping is now deployed and managed as a one unit. So the stateful set knows when you're defining a stateful set, or when the installation defines a stateful set, we are also defining in which order something should be deployed, and that is being kept track of by the stateful set. Right now, we only have support in BDC 2019, the released version. We have only support for one set of each type of pool, so one compute pool, one application pool, etc., etc. However, that doesn't mean that we are restricted to one instance of something. I mean, we can run multiple pods in a pool. And then the types of pools we're having is the compute pool, and I mentioned that briefly on Tuesday. That is what we are using to distribute out queries. So we have in the SQL master instance, we had something called the distributed query engine, and the distributed and scaled out query engine. So when we are executing a query against something, not necessarily against another database in your SQL instance, but for example against HDFS or whatever, this distributed query engine, this scale-out query engine, checks and sees basically, should I help this query to run by offloading it to the compute pool, where the compute pool now can share out the execution against multiple nodes of what I am querying. So that's the compute pool. The application pool is where you as a user, or you as a admin or whatever, where you are deploying applications to. So that could be, for example, that could be machine learning stuff, machine learning models. If you don't want to run that inside SQL Server machine learning services, but you can deploy now machine learning applications to the application pool. And also, if you, for example, would like to use SSIS, you would deploy that to the application pool. And then we have the storage pool and the data pool, which today's talk is all about. And so we're seeing here in the storage pool how we have stuff. We have some SQL storage instance, we have HDFS, and we have Spark. and in the data pool we have SQL instances that we use for storage, and we essentially use it for caching, and we'll talk more about that in a bit. Right, so a storage pool then. So this is now where you have the Hadoop file system. So Hadoop file system is, I mean, it's used mostly for delimited text data, for NoSQL related data. And we kind of use the Hadoop file system to build data lakes. And we can ingest data into the pool by using Spark. And the way we are accessing the data, once again, as I said in the beginning, we can use normal T-SQL to access data in Hadoop file system. And once again, by having a Hadoop file system, we can create a data lake. And I think I have here an example of that. In addition to have now the Hadoop data nodes here, right? We can also do something called HDFS tiering, where we are mounting an external HDFS store into the storage pool. So the data is no longer sitting in the storage pool, but it sits in that remote HDFS Hadoop file system store. And that's how so if you are using, for example, Azure Data Lake Gen 2, that's how you would now access data from your big data cluster against the data lake. You would mount the data lake into your storage pool. When we are deploying the storage pool, as I mentioned, it is deployed as a stateful set because we need persistence there, and we need complete control of what we are deploying and in which order we're deploying it. We are, as this is now HDFS, we are obviously deploying Hadoop file system data nodes. We are also deploying a SQL storage instance, and we're using, so now is the question, what do we use that storage for when we are essentially storing the data in Hadoop? Well, that is when we are, if we are executing, for example, queries, and we need to do some shuffling of data, we need to do some aggregation of the data, or essentially data overflow while we are executing. That's why we have storage instances there. Then we are installing something called collectd and fluentbit. And that is what collects logs from the parts now of the storage pool, right? So collectd collects logs, fluentbit kind of distributes the logs so that we can, through Grafana charts, etc., we can see exactly what happens in this particular pod, what happens with HDFS, etc., etc. Then if we're going back to the picture, right, actually this picture, we see here how we are saying that I have Spark here. That is not really true. I'm lying a little bit, but it's easier to visualize it like this. What we have is we're having a yarn container, yet another resource manager. So yarn is a resource manager, and it manages Spark. And if we need to do something Spark-like, then we are ingesting into the storage pool a container where Spark runs. Okay, so that's how it really works. But essentially, we are running Spark in the storage pool. Right. So now, how do we now get data into HDFS? And we have multiple ways we can do that. And one of the ways is basically ad hoc population, where we can use command line and a curl command to ingest data into the HDFS directory where we want it to go, or we are creating a directory together with the data. We can use the command line for that. The other way we can do it is to use Azure Data Studio, and I'll show you in a second how we can do that using Azure Data Studio. We also have, when we are installing a big data cluster, we are getting a command line tool called AZ Data, which is there for us to be able from command line interact with the big data cluster. And we can use the AZ Data to ingest data into HDFS as well. So it's AZ Data BCP copy, I think the command is. So that's ad hoc. We don't have, there is in the Apache Hadoop world, there is a tool called the distributed copy tool, which is a which we are using for large intranet cluster copying. In other words, we can copy data from one cluster to another, right? And it uses MapReduce under the covers to make the performance better. I personally haven't used the CP for this, but the Microsoft people saying that this works fine. And then finally, as I said a minute or so ago, we can use this tiering where we are mounting remote HDFS data sources into our storage pool. Right? So then let's have a look at that. Let's run some code. So here I have Azure Data Studio, and you who were in the session on Tuesday, you've seen this before. So this thing here, that BDC Ignite, that is now my my big data cluster running in Azure in Azure Kubernetes service, and we can see how I have various databases in here. But this is nothing different than what you would see, for example, in SQL Server Management Studio as well. However, since Azure Data Studio is supposed to be not a SQL tool per se as SSMS, but a data tool to use with all kinds of data. If you're noticing here, down here, how we have a directory called HDFS. And here is now where you can see the data that has been ingested into HDFS. And in a couple of slides time, we will see how we can actually access the data. But if we're looking here now, we're seeing how we have various directories. We have a directory called product review data, and in there we're having a CSV file with potentially product reviews, right? What we want to do is I have on my local file system, on my box here in Durban, South Africa, I have a CSV file called web/clickstream_DPG, Data Platform Geeks, which is 170 meg in size. And if we were to look at that file, it looks something like this, right? So we're having a header, which is kind of, well, like a little bit like columns, and then we have data, right? What we want to do is we want to create here a new directory, and we're calling that click stream DPG2. And then I want to upload files to that directory. So click upload, and we now choose my web/clickstream_dpg.csv file. We're saying upload, and seeing it's 175 meg, it will take a couple of minutes. So we will come back to this file after a minute or two. And let's go back here to my to the slide deck. So we have now the way we can now populate HDFS ad hoc. We use the Azure Data Studio way. We can use the distcp tool, or we can do tiering. The dependent upon what you are doing, what data you want to populate here. I assume that you will most likely use curl, Azure Data Studio, or HDFS tiering, dependent upon what data you want to populate HDFS with. So now, on Tuesday in the session, we said that data, we are exposing remote data through external tables, and we are exposing data, this remote data, through Polybase external tables. And in Polybase 2016 and 2017, for Hadoop data, we had a Hadoop data source, an explicit Hadoop data source type. And I believe, I'm not 100% certain, but I believe that that is still the case for your normal SQL Server 2019. The Polybase, we're using Java libraries. We used MapReduce if you want to do push down, where push down is where you are actually pushing down the query to the remote source, and the remote source is doing its bits and pieces and only returns the result set. 2016 and 2017, we're supporting text, Parquet, or C and RC file formats, and we could export to HDFS. And the problem here, it only works against Cloudera Hadoop or HD Insight Hadoop clusters. In 2019 Big Data Cluster, we are using SQL natively, so basically no Hadoop data source type. We are using SQL queries instead of Java libraries and pushdown, and we can query partitioned hive tables. We are not, in the big data cluster, we are not supporting ORC or RC file formats because they are not that widespread, let's call it popular, I don't know, but so mostly in Hadoop you will see either the limited text or Parquet, and that's why the big data cluster supports those two. And we are supporting tiering, as we've said before. Right, so external table then. So this is the general definition for creating an external table. And we can see here that we are saying create external table, we give it a name, we're having some column definition, then we're setting a location, data source, file format, etc., 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 right? So instead of going through slides for this, let's have a look at some code around it. Okay, so here I now have an Azure Data Studio notebook, and I spoke about notebooks in the Tuesday session, and I also spoke about notebooks in a webinar we had back in December. And I have here a database called Niels DPG4. So let's make sure that we are using that database. Let's make double sure. Yep, so we're in Niels DPG4. Actually, before we go any further, if we're now seeing here on the right-hand side, my clickstream DPG2, and we can see that I have now this file in there. That's cool. Let's do this. Let's preview. So we're clicking preview here. This file is too big to show all of it. So we'll just see part of it, and now it goes off and processes and looks at the file, and any second now we will get a preview of the file, I hope. Or not. Okay, there we go. So we can see that the file looks more or less like, well, looks exactly the same as we had in Sublime in my editor earlier. And I don't know if you saw down the right hand side here somewhere, it said that this had been now suppressed to 30 meg. So this is no bigger than 30 meg. But anyway, we can see that we have data there now. So now we have data in Hadoop, and it is CSV data. The question is then, how do we access this data? And well, we access the data through an external table, because on Tuesday I said we are using external tables to access data, remote data. But in order to access this data, we need to begin with a data source. So if you were here on Tuesday, you remember how I created a data source against my remote Oracle instance. We are doing the same thing here, where we are saying that we are creating an external data source, which we call SQL storage pool. And the name here is neither here nor there. It doesn't matter. You can call it whatever you want, but you can't have two with the same name. So I tend to, if I create an external data source against a storage pool, I normally call it SQL storage pool. If I create it against a data pool, I call it SQL data pool, but that is, the name doesn't matter. In the location here, we are saying that this is kind of the protocol that we are defining. When we did it for Oracle on Tuesday, we said it was Oracle. Now we are saying that it's SQL HDFS, SQL Hadoop file system. And we are pointing to where the Hadoop file system sits in my Kubernetes cluster, and it sits in a service called the controller service. And when we're saying default, we define that this is now going to the first storage node, which is stateful 0, if I remember correctly. Right? So we're creating the data source. Cool, we have commands completed successfully. And if we're going into my database here on the left-hand side, and we're looking at external resources, let's refresh. The external data sources, cool. We're seeing now here that we have actually two data sources. We have an Oracle connection that I created earlier today, and the storage pool here that we created just now. So this seems to work. Cool. So we have an external data source. Seeing now that this is a NoSQL, right? This is not your typical relational data. We need to create a file format for it. So what we are doing here, we are creating an external file format that I call a CSV file, because that's what it is. And when we are creating the file format, I am defining what type it is of the underlying data. In this case, it is delimited text, right? And then I have these format options. And in the format options, I say what terminates each field. As this is now comma separated, well, I'm defining it's a comma. And what is the string delimiter? And that is empty space here. And now if you remember, if you go back to my editor and we're looking at the file, part of the file, the first row is headers, or it is column names, or whatever it is, right? So when we go back to here, I need to define what in the file, what is the first row? Because I don't care. This is now used when we are selecting data out of there, for example, because I don't care about columns, etc. Because I will in a minute, in a second, or in a little while, create an external table where I define column names. Right? So here and now, so when we are reading in data from this file or from these files, because in my directory here, I can have many files, CSV files, right? When we read in now from each file, I am defining where is the first row of data sitting, and that is now row 2. And use type default is saying that if we're coming across null values, what should the default value be in kind of in SQL Server when we are retrieving data. So I'm saying use the type default for this. And then finally, before I forget, let's just change this to this. Right. So here. We are now creating an external table that we're calling web clickstreams HDFS CSV. We are defining, as we do with any table, external or internal, we are creating my columns. So, and all of this happens to be big int. Then we are saying where is the data source? Which data source should we use? Which is the SQL storage pool that we just created. And I don't think I created my file system, by the way. So let's do that. Cool. So we're saying that the data source is SQL storage pool. And now the location here is where we are pointing to this directory or potentially a particular file. So when we are pointing to clickstream DPG2, we will read in everything that is in this directory, every file that is in this directory. Or as I said, I could potentially just say clickstream DPG2 whack a file name, right? And then finally, what is the file format? Yeah. So easy peasy. We are executing that. We have created the external table, and now let's select against it. Whoa. Hello. HDFS query filed. Not found. That was interesting. Whoa. Two. Let's see if this works. This is not part of the show, but so I want to show you how to drop an external table. Drop external table, and we call the table that. Awesome. We have dropped the table. Let's recreate it, and let's use lowercase, because at the moment that's the only thing I think it could potentially be. So let's recreate it. That worked fine. And then let's select against the table. Cool. So what have we learned in school today? Well, we have learned that when we are setting up a location, the location name is case sensitive. So remember that when you are going forward. Cool. So we have now retrieved 10 rows from this table. And if we now say here, let's run this query. On Tuesday, I said that external tables do not have any data whatsoever. So let's run it. And we are now seeing here that we have null rows, null data, no index sizes whatsoever. So we are now executing, this query now goes down, and we are executing SQL queries against Hadoop. And that is fairly cool. We could do something like this, where WCS underscore pick underscore date underscore SK equals, let's take that, copy. Right, okay. So that should be okay, I hope. Let's run that and see if it works. Cool, 10 rows affected, and we're now getting data back. So now we have executed, me as a SQL developer, have now executed SQL code. I know SQL, hopefully. I have executed SQL code against Hadoop. I don't need to know Hive or Hive SQL or whatever. I can run SQL code against my Hadoop data, which is very, very powerful. And finally here is we can do something. So this now external table, it is just like a table, right? So we can now join my external table against, this table is in another database, and it is a normal SQL Server database, SQL Server data. So it's a relational table. We are joining against something else. And then I am also joining against an Oracle external table, right? So in here, I have a table called or underscore customer, and as I said, I created it earlier today, and it has around 500,000 entries in that table. I can run this query now exactly as I would do anything else, and this will run for a little while because it's quite a lot of data. Come on. It's still going. Let's instead go back to the slides. So we have seen that. One thing with the storage pool data source is that on Tuesday, I created a scoped credential against the Oracle database, Oracle instance. I don't need to do that here because we are not using authentication per se, or authentication is being used under the covers. We are instead using ACL checks against HDFS, and we have to have select permissions on the table. We have talked about file format. We have talked about the external table, and once again, remember location. Location is case sensitive. When we are now using this ACL, as I mentioned before, we are doing user impersonation, and Hadoop has basically two ways of doing user impersonation. They have the delegation token, HDT, or we have something called DoAs, which essentially as a proxy. And in the big data cluster, we're using the DoAs as impersonation. And when we're coming down to here, we can now see what happens that my user authenticates against SQL. We are sending user information along with the distributed query to the coordinator in the compute pool, and then the data warehouse, the PWD. So part of Polybase is the advanced data warehouse engine that uses DUAS in a web HDFS call to pass in the username to the name node of HDFS, and then we are getting file information, metadata, etc., etc., etc. Whereas the coordinator distributes the work across each compute pool instance, and each compute pool instance sends here an open row set bulk query to the storage pool instance together with your username, and the storage pool instance executes the open row set. So it's kind of and then data comes back. So that's how external table works, or how we are impersonating. Let's go back to this dude. And here we now have, I got back 9 rows, and this is now the result from this fairly complicated query. Cool. Let's see then. So that's that. All right, so let's go back to the slide, to the code for a second. Now here, and you might have seen this on Tuesday, but I'm gonna do it again for you who weren't here on Tuesday. So let's use my database. And here what we are doing is we are doing some aggregations, etc., where we are joining my HDFS table against a relational table in my sales database. So when I run that, this will take 16, 17 seconds. So the thing here now is that, especially when we are using Hadoop data sitting in Hadoop, the performance may not be the best, right? And here we're now saying a fairly simple query, 9 to, and that's where the data pool comes in. And the data pool consists, as we saw in the scary picture, consists of several SQL Server instances. And these SQL Server instances is essentially is persistent storage. So you can persist data in there. You can essentially cache data in the data pool to make performance better. Especially when you're going against remote data sources. And the data pool, we handle that through DDL statements. We can manipulate data, insert and delete data through your normal DML statements. And the scenarios for this is when we're having complex query joining against multiple data sources. We can offload storage of query from SQL master. We may want to do some machine learning stuff. We have a data scientist that needs millions and millions of rows that sits remotely to create a model. He most likely do not want to rerun against the remote data source every time that he wants to work with his model. So we could cache that data in the data pool. Right, and something that we at the Rivco are thinking about doing is to kind of use the data pool as an archive where we are offloading. So hot data sits in your normal SQL. Semi-hot or semi-cold data sits in the data pool, and then very cold data sits in the Hadoop file system. So that's a way we can deal with it. Once again, we are talking about stateful data, so we are deploying it at the stateful set. We are deploying a SQL Server instance, and we are deploying as before collect D and Fluent bit as we spoke about the storage pool. We have a special data source. So it's kind of where we are defining. So remember, for the storage pool, we said that it was SQL HDFS. Here it is SQL data pool. And it also goes against the controller service. The interesting thing here now is that when we are creating an external table in the data pool, the database that you are in, so in this case Niels DPG4, Niels DPG4 will be created in the data pool when you are creating an external table against the data pool. And then we can do alter database, we can do drop database, etc., on the data pool, and we can create indexes. So my external table will now be exposed in the data pool, and it will contain data, and the external tables has by default a column store index. When I'm ingesting data in the data pool, I can distribute it in multiple ways. Well, right now we have only two ways. One is round robin, where we are basically, so if I'm ingesting 500,000 rows, around 250 will be, and we have two instances, SQL instances. Around 250,000 will be inserted in one, and the other in the other. In the future, we will have where you can define distribution policies by a hash. So you're creating something that creates a hash over your data, and that will then handle the underlying architecture will handle where to put this data based upon your hash. And as I said, we can do select, we can do insert, and we can truncate a table and update statistics, sorry. Right, so let's go back to my data pool code, right? So what we are doing now here is that we're saying that I want to create an external data source, which I call SQL data pool. Once again, the name doesn't matter. It's the location that matters, right? And that the name is unique. So we're running that. We have created it. Let's create now my external table. So we're calling it web click stream clicks data pool. My data source is the SQL data pool, and I'm saying distribution round robin. So I want one row to go to one instance, the second to the second instance, and the third to the third if I have more instances, obviously. So we're creating that. And there we go. Now let's go down to here and see. Let's now look here. So the execute statement that we normally use for executing dynamic SQL, well, we are executing dynamic SQL, but anyway, the exec statement has been improved, and we can say where we want to execute this statement. So we're saying that, hey, I want to execute it in the data pool. Actually, let's run sys databases first. So run that, and come on. Oh, we're still running, sorry. So here we're now getting what databases we have in the data pool, and we can see that my database Niels DPG4 is here. So then let's do this. Let's select against Niels DBG for sys tables. And we will see, if I am correct, we will see now that I have two tables, two instances of the tables. They have the same object ID, but I have two instances of them. Cool. Now, Now what we want to do, we want to ingest some code. And we are running, we can ingest either through DML, or we can use Spark to ingest as well. But for now, let's just use normal DML. So insert into, select, I'm doing some calculations, some aggregations, etc., right? And let's run that. This will now take a little while to run. And let's go back to the slides for a second. Yes, we have seen that. We have created external data source. We have created external table. We have done the web clickstream clicks data pool, and that is running at the moment. And then we are almost done. So let's see that we are coming back to here. Okay, cool. So we're seeing now that we're seeing here how we, sorry, let's zoom in on that a little bit better. How we have 585,306 rows were affected by this insert statement, right? And let's just make sure that it works. We are selecting top 10. Cool, that's fine, that's great, that's good. And now let's use the same query as we had up at the very top, which took 19 seconds. Let's execute that. And this should take around 4 or 5 seconds now. Look at that. Look at that. So this took 4 seconds, almost 5 seconds. And here we see my data. Right. So now then, let's go down here a little bit further and do look at space used. So remember, here we saw we have 2 tables, right? And let's now look at space used. And if I am lying to you, you should see that, right, how we now have in one of the table, we have 293,000 rows, give or take, and in the other, we have 292,000. So we can see now here how my data during ingestion has been sharded out across the available data pool instances or available tables in the data pool instances. But me as a developer, I don't know that. I don't care. I'm just saying insert into and life is good. Right? Me as a developer, when I'm querying the data, I don't care. I'm saying select star from or whatever I'm saying, and I'll get the data. Very, very cool. So having done this, just 5 minutes late, not too bad. Summary. So for now, to be able to use data in the petabyte range, Microsoft has introduced the notion of storage pools, where we now can store data in a data lake, essentially, in the Hadoop file system. And then if we want to, and we can query that data, we can join against other tables. It's not a problem, right? The other thing is here too, for performance reasons or for offloading of query results reasons, we have the data pool where we can now shard out the data on SQL instances without me having to know, me as a developer ingesting the data, I don't have to know what it looks like. And me as a developer, when I'm retrieving the data, I don't know what it looks like. So that is that's that, my friends. So once again, thank you guys for taking time attending this webinar, and thank you, huge thank you to Data Platform Geeks that arranges these things, and you guys that are now here in this webinar, please can I phone a friend and tell them that how cool Data Platform Geeks is, and the awesomeness that people can get from Data Platform Geek. So once again, thank you guys. Do we have any questions?
Thank you so much, Niels, for once again for delivering a webinar with us. So before you take up the Q&A, let me just walk through a couple of slides more. So beyond this webinar, if you have any questions, you can post them in our social channels. There's a bit.ly link in the chat window. So bit.ly/DPG social. This is a link where you can get access to all our social channel links. So a quick word on our about our knowledge partner, SQL Maestros. SQL Maestros is coming up with its video courses. There are video courses on SQL Server Performance Tuning, T-SQL Querying, and T-SQL Programming. So this video course, it's going to be an advanced deep dive video course where you can watch anytime, anywhere, and as many times as you want. So if you wish to learn more about the video courses, you can just visit sqlmaestros.com, or you can also drop an email to contact@sqlmaestros.com. One of our team members will definitely reply with the details. So SQL Maestros has also relaunched its hands-on labs subscription model. So right now, if you purchase the labs, you can own them for life. So there are hands-on labs. The hands-on labs is basically a document-based learning where you'll be provided with the document with step-by-step procedures, instructions, observations, screenshots, and scripts. So by the end of each document, you'll be able to become an expert in that particular topic. So right now we have more than 100 labs on technologies related to SQL Server, Azure, Power BI, Analytics, etc. So you can go ahead and visit sqlmaestros.com for more details, or you can even drop an email. So right now there are a couple of free labs available. You can download them and practice them and later go ahead to purchase them. So with this, we are going to conclude the webinar. We have posted a thank you note on our LinkedIn and Facebook pages. So I'd request you all the attendees to please leave us some comments or feedback. This will definitely encourage our speakers to come back and deliver more sessions. So the links are available in the chat window, both Facebook and LinkedIn links. Niels, you can take over for the Q&A.
Cool, thank you. So there were 3 questions. First question was, how do I remote? How do I remove a SQL Server cluster instance from a node? And the answer to that is that you can use the AZ data. I remember in the beginning I mentioned AZ data, which is a command line tool for big data cluster. It works in both Azure as well as on-prem premises, on-prem installations. You can use that for the to manage your instances. The second question was here, so will database mirroring still be supported in 2019? Database mirroring, okay, so I answered that the preferred way of nowadays is to use availability groups. In BDC, big data cluster, database mirroring is not supported. As far as I know, I'm 99% certain that database mirroring is not supported. For bog standard SQL 2019, i.e. non-BDC, I am not sure. My gut says maybe. I'm not sure, but I mean, once again, availability groups is the way Microsoft wants us to go. And then the final question here is any significant improvement in DB column encryption features in 2019? I answered not really, but something that, and in the actual encryption, not that much improvement. However, what you should look at, I'll add something more here. Look at secure and enclaves. That is something new in 2019, and have a look at that and see if that gives you what you are after. So those were the questions I had that came. If you have questions, please post them on the LinkedIn or the Facebook according to the Facebook and LinkedIn links, so that the community can see the questions and help with answering. You are so that is the preferred way. But you are more than welcome to ping me directly and ask questions, comments, etc., etc. Finally, the slide deck for the Tuesday webinar is up at where the other slide decks are, and this slide deck as well. So you can go there, find the slide decks, have a look at it. I'll clean up my demo code for both webinars a bit and then post them as well. So once again, thank you guys, and thank you Data Platform Geeks.
Thank you very much, Niels, for taking out time for our community once again. Thank you so much, and thank you all the attendees. Kindly please post give us a comment or feedback in our post. I hope you can see the link in the chat window. So there are many more webinars and which is lined up for March. You can just visit our events page. The link is given in the chat window. And we have an in-person event on March 14th at Bangalore. So the theme will be SQL Server. Yeah, the link is in the chat window. You can refer the events page for more details. Thank you very much, Niels, and thank you all the attendees. Have a nice day.
Thank you, guys. Bye.